Hi, welcome to this lesson on Trigonometry, Trig Identities Part 1. Let's have a look at question 3. Prove the following identity and state any restrictions in the interval 0 degrees to 360 degrees, if there are any. Okay, so proving an identity has a standard form. We pick one side, either the left or the right-hand side, and we try to algebraically manipulate it to look like the other side, or if both sides are quite complex, we try to simplify them algebraically on both sides until they are equivalent. All right, so if I look at these two expressions, the right-hand side looks like it's a bit more complicated. So I'm going to start off with that side. So I'm going to say right-hand side equals sine theta plus cos theta minus 1 all over sine theta plus cos theta. So this is the entire denominator. And whenever I add or subtract fractions in algebra, I need to make sure each term has a lowest common denominator. So the LCD here would be sine theta plus cos theta, that entire expression. So I need to multiply every term by that. So I multiply sine theta by that. So sine theta plus cos theta. Plus I multiply this term cos theta by that entire expression, sine theta plus cos theta. And then minus, now that 1 over there, that's going to be dividing out with that base there, okay, and that's all over that common denominator, sine theta plus cos theta. Okay, because if I divide those out, I get sine theta, I divide those out, and I get cos theta, and I get minus 1 over sine theta plus cos theta for the third term. Okay, so now I'm going to do is expand the brackets out here. So sine times sine is sine squared theta, plus sine theta times cos theta. Okay, that's the first bracket expanded. Then plus cos theta times sine theta, plus cos theta times cos theta is cos squared theta, minus 1 all over sine theta plus cos theta. Okay, it's looking hopeful because now you can see we've got one fraction that looks like the left-hand side, sine theta plus cos theta in the denominator. But now I just need this expression left over algebraically. So I see there are two groups of sine theta cos theta. So I'm going to write 2 sine theta cos theta. Then I have a sine squared theta term plus a cos squared theta term. Now from your trig identities, right, that is the square identity. So sine squared theta plus cos squared theta is 1. And then there's a minus 1 term at the end here, all over sine theta plus cos theta. Now the positive 1 and the negative 1 will cancel, and you're left with 2 sine theta cos theta equals over sine theta plus cos theta, sorry, and that's equal to the left-hand side. So we've mathematically shown that the left-hand side is equal, or the right-hand side is equal to the left-hand side. Therefore, this identity is true. Okay, what about restrictions? So what do we mean by restrictions, and more so inside that given interval? Well, let's think about this. The left-hand side and the right-hand side both have fractions. And what do we worry about when it comes to fractions? Division by 0. Okay, because division by 0 is undefined. So can you see on the left-hand side, you have a denominator term of sine theta plus cos theta. Now that can never equal 0, because if it does equal 0, then we're in trouble. Because then this left-hand side is division by 0, and this right-hand side here has division by 0. So the restrictions are when your theta values attain that equality. So I mean, when is sine theta plus cos theta equal to 0? Well, this is a trigonometric equation, so we can solve it. So what I'm going to do is I'm going to divide both sides by cos theta. Okay, so if we do that, what do we get? So we're going to get sine theta divided by cos theta, that's tan theta. Cos theta divided by cos theta is 1, and 0 divided by cos theta is 0. So now I have a trig equation with just one trig ratio and a constant. So I can say tan of theta equals negative 1. So that is the trig equation that we're going to solve. And once we solve that, we'll get a general solution. And then those values that's satisfied inside this interval will be our given restriction. Okay, so let's make some space here. I'm going to just clear this all. Okay, so we are solving this equation here, tan theta equals -1. So we do the usual steps of a trigonometric equation. You're going to find your theta reference angle, which is going to be tan inverse of the positive number, and tan inverse of 1 is just 45 degrees. Okay, so on your cast diagram, there's your reference angle, 45 degrees. But tan was negative, and tan is negative in the second and the fourth quadrants. So therefore, in the second quadrant, your solution is theta is 180 degrees minus the reference angle, which is equal to 135 degrees, plus k times the period of tan is 180 degrees, where k is an integer. Or the fourth quadrant solution is going to be when theta is 360 degrees minus the reference angle. So that's going to be 315 degrees plus k times 180, where k is an integer. So those are the general solutions. But we are only interested when the solutions are between 0 and 360. So let's pull out the k values for each quadrant and then see what happens. So when k is 0, I get 135 degrees. And that does fall inside this interval here. So that's definitely a restricted value. What about k less than or equal to -1? Okay, because remember these are integers. So -1, -2, -3, -4. Well, if I even just put -1 here, first of all, my theta is definitely going to be less than 0 degrees, which is outside that given restriction. So no applicable solutions here in that side, because as you get more negative, you're going to get less than 0. Okay, what about k greater than or equals to 1? So if I put 1 here, 180 and 135, that's going to be 300 and, well, let's double check. 135 plus 180, 315 degrees. So theta equals 315 degrees. That's still inside that's given domain here. But can you see this is the only solution, because the moment you go to k equals 2 and onwards, so you're going to get 135 plus 360, you're going to get values bigger than 360. So this is the only applicable solution there. Okay, and the same thing I can do for quadrant 4. If k is 0, theta is 315 degrees, which we expected. Okay, that's a valid solution. If k is less than or equals to -1, then let's see, at -1, you're going to get 315 minus 1 amounts of 180. You get 135 degrees, which we expected to be a solution. But anything less than -1, so -2 onwards, you won't have solutions. And then k greater than or equals to 1, that value is definitely going to be bigger than 360 degrees. Okay, so there's only 2 restrictions. The restrictions are theta cannot be equal to 135 degrees, and theta cannot be equal to 315 degrees. Otherwise, this identity is always true inside that interval. And you can double check. If you take your calculator on the left-hand side identity, if you could take 2 sine, let's say 135, okay, that was one of the restricted angles, cos of 135, all over sine 135 plus cos 135. If I do that, I get an error. Okay, and that's to be expected. All right, so that's how we would do this type of question. I'll see you in the next one.